Welcome to the first video lecture for ENSC 2613. Today we will be talking about some basic components that you will encounter during circuit analysis, as well as going over Ohm's law. Some basic components that you will use commonly are voltage sources, current sources, resistors, inductors, capacitors, and the ground. A voltage source is used to set a specific voltage difference between two nodes. A current source sets a specific current through a branch. A resistor is used as energy dissipation. It's typically used to model a light bulb or a motor or any other device. An inductor and a capacitor are both used for energy storage. We will cover these in great detail at a later date. And the ground indicator is a way of denoting which node we are considering to have a voltage of 0 volts. And the other node voltages in our circuit will all be in reference to this node. When we talk about nodes, we are referring to the wires that are connecting all of our components together. In this particular circuit, you can see there are 3 different nodes, a red, a blue, and a green. Anytime that we refer to a voltage in this circuit, we are referring to the voltage of a specific node in reference to another point. Where nodes only contained wires, branches actually contain the components themselves, and a branch is a path for current to flow through. You'll see in the circuit example that there are 3 branches. There's a black branch that wraps through the voltage source and the top resistor, and then it has to split into the red and blue branches, and they will join back together at the bottom. Whenever we talk about currents in this course, we are always talking about the current through a branch. Now that we've covered the basics, it's time to go over Ohm's law. Ohm's law in its simplest form is V equals I times R. That being said, we need to cover a few conventions that we are always using. We always have the polarity of the voltage across the resistor with the positive point opposing the direction of the current arrow. And then the voltage is not the voltage source, but it is just the voltage that is dropping across that resistor. Now we will work a few sample problems. In the first problem, we are asked to find V, where V is the voltage drop across the resistor. The current going through the resistor is supplied by this current source and has a value of 5 amps. The resistance has a value of 2 ohms. Knowing that V is equal to I times R, and that's 5 times 2, we have a voltage drop of 10 volts. Now let's move on to our second problem. In the second problem, we are asked to find the current that is traveling through the resistor. In order to use Ohm's law, we have to consider the voltage that is across the resistor itself. So we have to look at what the circuit is giving us. On the bottom of the resistor, we know we have 0 volts because we are connected to the reference point on the bottom node. On the top node, we have 9 volts because the voltage source tells us that there is a difference of 9 volts from the top and bottom node. Using a manipulation of Ohm's law, I is equal to V over R, we can say that I is equal to 9 minus 0 divided by the 3 ohms to give us 3 amps. Let's move on to problem 3. In problem 3, we are asked to find R, which is the value of the resistor. We know that we have to use the voltage that is across the resistor, and so using the same logic as before, we have 0 on the bottom because it is connected to the ground node, and the top node is 12 because of the 12 volt voltage source. We can manipulate Ohm's law to be R equals V over I, so that means that R is equal to 12 minus 0, which is the difference in voltage across the resistor, divided by the 2 amps. This results in a 6 ohm resistor. The last thing we have is a bonus problem. I want you guys to see if you can find I in this circuit. We've given you the answer so you can check your work. If you have problems working out this problem, please contact your instructor or teaching assistants and they'll be happy to help you. This concludes the first video tutorial for ENSC 2613. Come back next time and we'll cover Kirchhoff's law.